Well, hello there. This is Mr. Kingsbury, and today we're going to talk about the Unit 2.04 notes. And actually, I'm about to reveal to you a different way to divide polynomials. In fact, it's a very easy way. Many of you are going to be very upset that I did not share this with you earlier. The reason I did not is because you needed to learn to do it the long way first. The other thing you have to understand is that while this way is amazing, it does not work for every single polynomial division problem. It only works for ones where we are dividing by a binomial, where the coefficient of x is 1. So unfortunately, it's not the end-all be-all. It does not do every single problem, but it does do a bunch of them, which is great. So let me just walk you through a problem or two. I know there are 8 problems on your notes. I'm not going to do all of them. I will do some of them, maybe 4 of them, and then I will post something that has all of them worked out for you. Let's, as always, start with number 1, and let's just look and see what's there. So we've got 2x squared minus x minus 3 divided by x plus 1. Now, as always, I'm going to check and make sure there aren't any missing terms. In my dividend, I've got x squared as my biggest exponent. So I need an x squared, I need an x, and I need a constant. Got it. And then in my divisor, I have an x and I have a constant. There's nothing missing there. Beautiful. The other thing that I'm going to do is I'm going to make sure that everything in the actually, I'm going to make sure everything has a coefficient. I got a 2 here. I don't have 1 here, so I'm going to go ahead and put that 1 in there. I got my negative 3 is good. Then over here, I got x plus 1. I'm going to go ahead and put a 1 in there. Truthfully, this isn't going to make any difference, but I'm being consistent. And now that I've done that, I can show you how to do something called synthetic division. S-Y-N-T-H-E-T-I-C. Synthetic division. I honestly don't know how it got that name, but it's pretty cool. Now, synthetic division does not use any of the variables, and that's part of the reason students really like this method. It doesn't actually use letters. It just uses the coefficients. It's pretty awesome. So what I'm going to do is take these coefficients from my dividend, 2, negative 1, and negative 3. I'm just going to write them out. And then I'm going to put an upside down division sign, and I'm going to leave space between the numbers and the bottom of my division sign. I need that because I'm going to be putting numbers here. Then I'm going to come over to my divisor, and I'm going to take this number here, and I'm going to put it outside. I'm not going to take the x, just going to take the 1. Now, normally, we would divide, then multiply, then subtract, then bring down. Synthetic division is going to make that a little bit simpler. We could absolutely do a couple of those steps, particularly the one where we subtract. We could absolutely do that. I have found that when I ask people to subtract, they sometimes forget. And so it is more successful when people add. So I'm going to make one adjustment. I took this 1 here, and I put it here. And now I'm going to change its sign. It was a positive 1. I'm going to make it a negative 1. By doing that, I've made it so all we have to do is, during the process, we will have to add down in some columns. This way, the signs are taken care of, and there's less of a chance that we will miss some kind of sign change, or we'll end up combining them wrong or something. Now, before you do the actual process, you always bring down the first coefficient, and you write it underneath the line. That's what's going to get us started. And then after that, you're going to do the same 3 steps. You're going to multiply whatever you just wrote underneath by this number, So multiply and then write it under the next number in the series. So I'm going to go 2 times negative 1. That's negative 2. I'm going to write that right here, negative 2. So multiply, write, and then you're going to add down. Negative 1 plus negative 2 is negative 3. And then you repeat the process. But now you do it with this new number. Whatever's the most recent thing you just wrote under the line, that's what you multiply with. So now I'm going to go negative 3 times negative 1, which is positive 3. And I'm going to write it under the next number in the series, which would be negative 3. And then I'm going to add down. Negative 3 plus 3 is 0. So now I have this. The question then is, how do I interpret it? Well, if you remember, this was 2x squared, negative 1x, and negative 3. So if we started with 2x squared, our answer will start with a variable raised to the exponent that is 1 less than this. So this started with x to the second power. This will start with just x. And then it will go down from there. So we got 2x, and then I would do minus 3, and then see this 0? That's the remainder. There are no remainders. So our answer is 2x minus 3. Now, if there had been a third term, then that would have been an x squared term. And in fact, I'm going to show you that next here in just a second. That's all there is with synthetic division. And I got to be honest, it's very simple. In fact, it's almost too simple. People ask all the time if I'm making it up or if I'm lying to them or if there's more. They feel like there should be more. There should not. It is that simple. I said I'm going to do number 2, but I changed my mind and I'm going to do number 3. So number 3 is 5x cubed minus 8x squared plus 10x minus 16. We're going to divide that by x minus 4. So we're starting with x cubed. Do we have all of our terms? X to the third, x to the second, x constant. Check. Just x constant. Check. Does everything have a coefficient? We're good. We can put the 1 on here if you want, but you know what? It's not going to make a whole lot of difference. Let's write out our constants. And do not forget, I'm sorry, not constants, coefficients. Do not forget these negatives. It's 5, negative 8, 10, and negative 16. We write our upside down division sign. And then we'll take this number, negative 4. We're going to change the sign so that it's positive 4. We're going to bring down the 5, and then we can get started. 5 times 4 is 20. I put 20 here, and I add down. Negative 8 plus 20 is 12. 4 times 12 is 48. And I add down. 48 plus 10 is 58. 58 times 4 is a pretty big number. 212, I do believe. And then we add 212 and 16. And you get 196, I think. Yep, 196. So now let's interpret this. Remember, we started with x cubed, so this will start with x squared. And then that's a positive 12, so plus 12x. That's a positive 58, so plus 58. And then that's a positive 196, so plus. And then this is my remainder. We have a remainder on this one, so I'm going to go plus 196 over x minus 4. Remember, we've talked in previous videos about how we write a remainder as a fraction with what's left on top and the dividend, I believe, underneath. That's synthetic division. Pretty straightforward. Pretty easy. Some people think it's too good to be true. I can understand that. Let's check out number 4. So number 4 is 4x cubed minus 15x squared plus 3x. And we are going to divide that by x minus 8. First things first, I want to make sure I have all my terms. So we're starting with x cubed. So I should have an x cubed, then an x squared, then an x, then a constant. I don't have a constant, so I'm going to rewrite this as 4x cubed minus 15x squared plus 3x plus 0. And we'll divide that by x minus 8. Now I can do my thing. So 4, negative 15, 3, and 0. This is a negative 8 here, so I will write positive 8 here. We bring down the 4. 4 times 8 is 32. Negative 15 and 32 is 17. Oh, this is going to be big. 8 times 17 is 136. And 136 times plus 3 is 139. Oh my goodness. And then 8 times 139. This is big. So let's see. I'm doing this in my head. 8 times 9 is 72. So I put the 2 and I carry the 7. 8 times 3 is 24. Plus 7 is 31. So we put a 1 and carry the 3. 8 times 1 is 8 plus 3 is 11. So 1,112 plus 0 is 1,112. And let's interpret the answer. So we started with an x cubed. This will start with x squared. So 4x squared plus 17x plus 139 plus 1,112 over x minus 8. All done. And the rest are pretty much the same. So what I will do, I know I said I was going to do 4, but I'm just going to leave it at 3. And I will make sure to post a worked out version of all 8 of these for you. Okay? Thanks for playing. Have a great day, and I'll see you in class.